Dear students, we'll have a discussion about design methodology. In this module, we'll have to look into the design flow which is used in VLSI design, then design optimization, then design for testing, it's also called as DFT, and non-technical issues. Now, the design flow. So in this diagram, the complete process of IC design from the scratch till the fabrication, the entire process is described here. So as we discussed in the module 1, so same diagram we discussed there. So there's a correction, this block is empty, so make it as hardware integration. Need to look into the requirements for the particular IC design and constraints. Then proceed with the architecture exploration and partitioning. Can be partitioned into two requirements. One is hardware requirement and its constraints. Another one is software requirements and its constraints. And then individually you'll have to look into software unit design, then a software unit verification, parallelly hardware requirement and constraints, then design of hardware for the particular unit, then verification of that hardware. So these both need to be verified. Hardware unit has to be verified with the software verification. Similarly, software unit has to be verified with the hardware unit. If everything goes fine, then proceed with the software integration. Similarly, here it is for hardware integration. In this block, we'll write it as hardware integration. If any corrections required or any modifications required, I can go back to the unit design or for the architecture partition and exploration. And again, we'll have to continue with the same procedure. So once the software integration and hardware integration is completed, then we'll have to proceed with the next stage. It is software integration verification and hardware integration verification. If both are fine, proceed for the synthesis, then post synthesis verification. If that's fine, proceed for the physical implementation, then physical verification. If you find any difficulties or corrections required, you can go back to any stage and do the modifications and come back, like physical implementation, synthesis, or the hardware or software unit design. If everything is fine with the physical implementation and verification, then it can be proceeded for the same particular IC can be used for the fabrication. Once the fabrication is over, it has to be tested. So this is the procedure used in the ASIC or VLSI design. I think this we discussed in the module 1. Just recap the same thing. Now proceeding to the next topic, that architecture exploration is classified or divided into some particular blocks. And this is the one important thing, and given the question with the question bank. So you need to concentrate with the block and look into the edge detector meaning, which is nothing but used to identify a shape in the video or changes in the video. That's the major thing here. So that's the explanation. Now, coming to the DFT, design for test. So I think I need to give some introduction to the design for test. See, once the chips have been manufactured, they must be tested to ensure that they work correctly. There are some reasons why manufactured chip may not work, including problems arising during wafer manufacture or during packaging, both for manufacturing of ASICs or FPGAs. Now, in order to reduce the defects and to reduce the cost required for the testing, different kinds of design for testing we have. So that can be incorporated for a complete batch of chips, so that we can avoid the failure of chips. That's the agenda of DFT. Why do we use DFT is to reduce the number of chips failure, so that the production can be increased and the testing time can be reduced. That's what I said. We can reduce the time and cost involved in the testing system by including the additional circuitry. See, in DFT we have one method. So additional circuitry for the chip to be tested will be having an additional circuitry, so that which can be tested and which reduces the time required for the testing and cost required for the testing. So that's why we name it as design for testing, which provides a circuitry such as such that circuit includes additional circuit includes elements to that makes internal nodes which can observe or that perform testing automatically as a special mode of system operation. Design for testing can be classified into three techniques. One is a fault model and fault simulation. Second one, scan design and bound to scan. The next one is built-in self-test. So these are the three methods followed be followed or to be understand, and each is having its merits and demerits, and all three are important. And I need to discuss about built-in self-test. We'll be taking after this session. Thank you for hearing patiently.